What's up, everybody? I'm the Nature Hacker, and this is your world. So today I'm going to talk about electric fusion. This is a theory to explain how gold is created in the earth. If you look at one of my previous videos, just a couple back or so, you'll notice that I did something about creating gold from rust and crystals. And basically the rundown of that is you're using hydrogen sulfide or hydrogen telluride gas to impart a strong negative electric charge onto hematite, an oxide of iron, and that electric charge makes iron basically convert into gold. Now, I've been doing some calculations about how exactly this would happen, how exactly, do the neutron numbers add up? Do the proton numbers add up to create gold from iron? Or, more specifically from hematite or, any type of iron oxide. And it seems like what would be required for it would be 2 irons and it's 3 irons and 2 oxygens. So irons typically have 56 protons and neutrons. Oxygens always have 16. So 3 times 56 plus 2 times 16 is 200. So gold has 197 protons and neutrons. So we have 3 extra when we do that. And those 3, basically what happens is they fission off. But anyway, so let me get to the end from the beginning. And the end is that we're creating plutonium 200. Okay, so we add those 3 irons and 2 oxygens and we get 94 protons. That is plutonium. Now we have 94 protons and only 200 total protons and neutrons. So this is a very light plutonium. And this plutonium would theoretically degrade into, obviously gold 197. So it gives up 15 beta particles and 3 neutrons to create gold 197. So plutonium 200 is what we're creating, and plutonium 200 will degrade by giving out 15 beta particles and 3 neutrons. I don't know which it would give up first or if it does them interchangeably, but we know that these things like plutonium can spontaneously fission and give off neutrons. So it fissions 3 times, gives off 3 neutrons, loses 15 beta particles, and becomes gold 197. So that's what we're doing. We're creating plutonium with 3 irons and 2 oxygens. Unfortunately, you can't see my mouse pointer. I can try to point here. So now, how are we doing that? Before I was thinking, we're creating neutrons. The neutrons are hitting. This is hematite over here, and the neutrons are hitting over here and converting some of these irons. We're hitting with electric charge. We're getting a electric charge hitting this iron, converting some of the protons into neutrons, which go off and hit other ones, and it doesn't really work that way. So what's happening is that we're not creating neutrons first. We're creating the plutonium first, plutonium 94 first. Well, plutonium is 94. We're creating the plutonium 200, the isotope of plutonium. We're creating that first, and then it's going to give off its own neutrons after that. So really the neutrons are not the cause, they are rather the effect. So what's happening is we're using this strong electric field to create oxygen holes. Let me look really quick what that's called. Oxygen vacancies. Okay. So what we're doing is we're using a strong electric field to create oxygen vacancies, and we know that this can happen in a very strong electric field, whether it's plasma or just electric field in general, we can create oxygen vacancies and things. So, here up here is magnetite, over here is hematite. Now, we're going into this knowing that prospectors have always said redder is better for finding gold in iron-containing things. So redder is better, which means we're going to want to find more hematite than magnetite. Magnetite's the black sand stuff. So, so knowing that, we're like, well, how would hematite be better than magnetite for creating these oxygen vacancies? Now, let's say we did an oxygen vacancy over here in hematite. We took out one of this oxygen right here. Sorry, I can't point on top of it, but we're taking out that oxygen right there, the one closest to my finger. What would happen? Well, we have 3 irons that are bound to that oxygen. Now, if that oxygen goes away, those 3 irons are just sitting there with nothing in between them. Now, they're still going to stay there because they're positively charged, so they're going to repel each other. But let's say we neutralize the positive charge on all of those irons, which is probably the way you get the oxygen defect. What is that called again? Vacancy. That's the way you get that oxygen vacancy, is you do neutralize the irons, these are iron plus 3 charge. Now, plus is a positive charge, electrons are negative charge. So you're using strong negative charge to neutralize those irons, and those oxygens can just escape out, basically. I don't really know the exact mechanism of it, but I know that we can create, scientifically verified that we can create oxygen vacancies with a strong electric charge. So we get these oxygens out. Now we have these 3 irons. Now, with that strong electric charge, those irons are going to be neutralized, so they're no longer going to be repelling each other. So you got these 3 irons there. Now they're neutral, and they can just basically implode, and then I guess bring 2 oxygens with them is kind of how it would happen. So let's see, we got those 3 irons there. Let's say this oxygen gets boinked out, the one in the middle. Do we have 2 more oxygens easily? Yeah, we got a couple oxygens bound. We got that oxygen, we got that oxygen that can kind of just collapse in with those 3 irons and form plutonium-200. So this is called what I'm going to term electric fusion. There's plenty of weird names I could have come up with, like lattice implosion. This is a crystal lattice, so you could say lattice implosion or something. But I think electric fusion is a better way to explain it, because we're using electricity to cause oxygen vacancies, which can allow these atoms to fuse together from those vacancies, and with the neutralized charge can allow them to fuse together. So that's the mechanism behind electric fusion. Now, if we look at magnetite, why would this or would this not work with magnetite? Well, we've only got 2 irons connected to each oxygen. If you look at any given oxygen, there's only 2 irons connected. So if you got rid of one of those oxygens, only 2 irons could possibly fuse together, and that obviously wouldn't create the plutonium that we need to create gold. But also what we've got here is when you remove that oxygen, all of those supports in there, those scaffolding, bond type things, there's some big levers created. Like you take out one of those oxygens and you got some big levers. Like if you take out an oxygen here, you don't really have any like levers created. When I mean lever is like, let's say your bonds look like this. If you want to combine these 2 together, you kind of have to squish this bond angle in here, which takes energy to do. But what if you get rid of one of those oxygens and you look like this? Now it's like a lever. It's gonna like collapse those 2 irons together. So you got much bigger bond angles over here. So they're going to kind of act as a lever when you remove one of those oxygens. So this might be kind of like giving us some leverage to actually create this electric fusion. Just in hematite, because the bond angles are greater than in magnetite. So we're getting more of a lever action happening. So we got our 3 irons. Basically, when we neutralize their charge, the rest of that structure is going to want to collapse in on there. So it's basically like a little implosion in the crystal structure when we remove one of those oxygens and neutralize the charges on the iron 3 ions. So that's the theory on how electric fusion happens. So really all it takes is a very strong electric charge. Very strong electric charge. That electric charge does 2 things. It creates oxygen vacancies. It could just be one thing. This is probably one and the same, creating the oxygen vacancies and neutralizing the positive charge in the irons. So that's all we need is a strong electric charge with not reacting it. Basically, we want a strong electric charge where there's no other ions bonding in there. We can have just SH, an SH ion come in and induce a strong electric charge, but it's going to bond. It's going to use that electric charge to bond to the iron, which would form fool's gold. But if we don't allow that SH to bind on there by having a crystal, a quartz crystal between the two, the charge can be transferred through the quartz crystal without the SH transferring. So the SH stays safely over here, but it transfers its charge to the other side of the crystal, which then over here we've got the hematite, that stuff, the hematite. So we get the charge without the actual chemical bond. So we're kind of doing a mixture of chemistry and physics. We're using bond type energy, the electrons, but we're not allowing a chemical bond to happen. So what happens is we get what's called electric fusion, lattice disintegration, lattice collapse, lattice implosion, whatever you want to call it, crystal lattice implosion. I like to call it electric fusion. So that's what happens. We have such a strong negative charge that it would really want to bond chemically to whatever's creating that charge, but it can't by the crystal or whatever. So it fuses in on itself. So when that happens, we get 3 neutrons released and 15 beta particles. So my prediction would be every theory has to explain, and not contradict experimental results. That's number 1. A theory has to explain a phenomenon without conflicting experimental results in the field and make predictions so that it can be verified in the future. So 1, I'm explaining how the geology of gold is found. That's what I'm doing here. I'm explaining how the geology of gold is found. Gold is always found with hematite. It's always found with iron, preferably hematite. And it's always found around quartz crystals, and it's usually found with high sodium concentrations, which is high alkalinity, and it's also found in, earthquake areas, which is high in hydrogen sulfide. All these things are explained by this theory, okay? The hydrogen sulfide is the electron donor, especially when it's converted to SH from the alkaline conditions, etc. Okay, so I'm explaining the geology of gold. Now, I'm doing that without conflicting any experimental results. Okay, experimentally we know that we can induce oxygen vacancies using a strong electric charge. Obviously, we can neutralize these iron 3 with a strong electric charge. So, I'm not conflicting any experimental evidence, and I'm proposing a new theory which does that. And the predictions would be that we're getting that when we hit this thing with a strong electric charge and don't allow anything to chemically bond to it, we're going to see neutron release and especially beta particle release. So we're going to see even a Geiger counter should probably be able to pick it up. If we're getting 15 beta particles for each thing of gold created, that's a lot. That's insane amounts of radiation. So we should be able to pick that up with just a Geiger counter, just a typical Geiger counter. If we're doing this on a good scale, we should see that on a Geiger counter. And obviously, if we had a neutron scintillator detector, we should also see neutrons released. So that is how gold is created. That same process would be for other metals. You can look up the geology of iridium. You can look up the geology of platinum. Hint on platinum, I think it's manganese would be like the iron equivalent for making platinum. So probably manganese oxide. Same type of principle would occur with a manganese oxide crystal structure. So with platinum. So anyway, iron, gold, this is how it's created. It's created through the intermediate plutonium-200, which is really interesting. Isn't it interesting when you add up those 3 irons and 2 oxygens to get as close as you can to the atomic weight of gold? Also, it gives you plutonium in the proton, so that means it's going to have some of the properties of plutonium, like being very fissile and radioactive and stuff. So that wouldn't surprise us that plutonium can eject 15 beta particles and 3 neutrons to create a stable element, gold. So I guess you could ask, well, why does it form gold when you make those? Well, because it's really close to gold on on its atomic mass. So it's like everything in nature wants to take the path of least resistance. So emitting beta particles is easier than emitting neutrons from a nucleus. So it's going to want to do that. It's going to want to create whatever it's close to in neutrons, in atomic mass, which would be gold 197. So that's pretty much it. Let's see, 197. So yeah, that's the theory on how gold is created in the earth. This is a more specific theory, more like exactly how things are happening. So all we need is an electric charge and prevent any ions from reacting with it. So we could even possibly do this with electrolysis. Let's say you have your 2 iron electrodes in alkaline conditions. I would say probably is best alkaline. One of them's turning into hematite, that stuff over there, and the other one's turning into probably reduced iron, maybe some magnetite, stuff like that. But so maybe on the inside, you've got in your electrolyte, it's got stuff that wants to react, but on the inside in here, you're pushing electrons on one of these, and from the inside, the electrons could hit the iron oxide, converting it via the oxygen vacancy electric fusion into gold. So it is possible to do an electrolysis. It's probably harder than the H2S crystal method that the Earth uses apparently to create gold. But once you know how exactly this works, you know how to do it. Maybe you could use light to do it. Like a magnifying glass, something like that. Because light, I believe that photons are actually just teeny electrons. They're like electrinos is a photon. So when you know that also opens up some possibilities. So anyway, the key here is just a strong electric charge without letting it react with something, and we will have electric fusion and basically the collapse of this crystal lattice into gold. And that does line up with how we see gold. We usually see, when you look at hematite with gold, it looks like the gold melted into the hematite, but somehow the hematite that it melted into is magically gone. So this would explain why, is that iron is converted into gold, and that's how it works. So strong electric charge, very, very, very strong electric charge to get that to happen. So I'm working on electrolysis right now, trying to get some gold produced, but it's hard, and you're probably going to get very little. That's going to be difficult to to purify out and define. So really the best way to verify you're doing this is to look for beta radiation. So that is what the theory would suggest. Anyway, I can't really think of anything else I want to add. Let me see if anybody's watching and have comments. Anybody there? See that I've talked. Alright, let's see what people said. Well, talking about creating plutonium isn't that bad to talk about. Well, this is a very transistory plutonium. This is not plutonium that could be purified or stored or anything like that. This is instantaneous degrading plutonium that would definitely not be able to be measured, let alone concentrated. So no, it's not a dangerous thing. It is dangerous in the sense this is going to be emitting a lot of radiation, so you need to be very careful with that. This should be done underground so that radiation is not emitted. Let's see. Geo Straber saying, looking forward to showing me why I'm wrong. Yep, good. Looking forward to that. Gold alchemy, yes. Electric fusion of GM paint job, yeah. Yep. You can sure plate things in gold with electrolysis. Yes, you can. Alright. Yeah, and I'm going to be debating Geo Straber, so that will be interesting. Photons can't be electrons, huge mass difference. Well, sure, but you know, let's say it's 200 photons make up an electron or something, you know, so, and you know, mass can be, you know, it's how it's measured, right? How can you measure the mass of a photon? It's very difficult. So, you know, it just depends on the methods of measurement of mass to why there could be any discrepancy between electron and photon mass. But we do know that emitting photons does give you a mass recoil effect. You know, there's been like NASA type experiments where they're like, I don't understand how we could get recoil energy from photons because photons don't have any mass, but we do get recoil energy. So, well, genius, that means that the photons probably do have mass. So, yeah, anyway, I think that photons and electrons, I mean, that's a good point though. That would be one possible contradiction for that theory, but like I said, there could be other reasons why the mass might not be easy to see the difference or be easy to line up between photons and electrons. But everything else, all the other experiments and things, are not contradicted by saying that electrons may be made out of photons. So, you know, we obviously know that, you know, electron excitation can decrease when it emits a photon. We can get, you know, things like that. So yeah, anyway, we can talk about that another time, but so yeah, that is basically the theory. We got electric fusion by creating oxygen vacancies and thereby collapse of iron atoms and oxygen atoms. And so obviously to test this theory would be to see if any beta or neutron radiation is coming off of this. So thanks for watching. This is just giving a little more in-depth explanation of how gold could be created in the earth using my last video and possibly electrolysis. So thanks for watching and happy experiments. Let's do work.